Hello everyone, welcome to Getting Started with Hadoop Ecosystem Core Components course. We are with Module 5, which is all about handling unstructured dataset using MapReduce. So why to handle unstructured dataset using MapReduce? Basically, we have seen like we can handle structured data using the word count problem. Then images, audio, video, these are all the new dimension which is there in current big data problem, and MapReduce allows us to solve these kind of problems as well. So about OdinSchool is a technology upskilling platform. We help you continuously acquire new skills. So stay skilled, stay ahead. Talking about myself, my name is Tushar Kakaya. I'm having 8 plus years of IT experience working with various forms of data. My main skill set includes Microsoft Business Intelligence, Hadoop ecosystem components, big data analytics using Apache Spark. I have worked with various tools like Cloudera, SQL Server Management Studio. The domain's expertise lies in telecommunication domain. So in today's session, the agenda would be understanding NCDC dataset, which is for the climate data center. Then we will analyze the weather dataset using Java MapReduce. And finally, we will perform image processing using MapReduce. So let us understand the NCDC dataset. It is all about National Climatic Data Center. Basically, this is the organization which is providing us the dataset for various years at different time points, and you will be seeing the dataset is having a fixed length, ASCII format, each line in a record. So that format is actually uh, giving you some optional or variable data lengths, and we will focus basically in from this dataset like every year what is the temperature basically. So this is the particular website you can just visit and see the daily temperatures which are recorded throughout the year. Okay, so they are having a huge data set for each year, each day, each hour, each 15 minutes or something like that. Okay, so they are recording the temperature for some x and y axis, and we are interested to find out you know the maximum temperature for that entire year. Okay, so that is our the business problem which we will be solving using MapReduce. So we have seen MapReduce is able to solve word count kind of problem, right? That is a classic example. But how MapReduce can help you to mine this kind of structured data set, that also we are going to see. So for MapReduce, generally people are bound with only word count problem, but I just want to show you MapReduce can help you to mine something other than word count also. So I'm just giving you something for practice, and that is all about NCDC dataset. Let us quickly revise what our MapReduce is doing. So MapReduce is actually working by breaking the processing into two phases. The first phase would be nothing but map phase. The second one will be nothing but reduce phase. Basically, you will getting a file, you will convert into the key value pair. First one would be nothing but the character position, and second one would be nothing but the line. So that way you will be getting some key value pair. From this key value pair, the line would be your input, and you will apply some business logic and generate some another key value pair like k1 v1, k2 v2, k1 v3, k2 v4, k3 v1, something like this. Then sorting and shuffling happens, which will sort the keys in ascending order and shuffle all the keys together. Then the reducer will actually perform aggregate on the same key. That means K1, and we are having V1, V2. There are two values. Then for K2, we are having, sorry, for K1, we are having V1 and V3, right? For K2, we are having V2 and V4. For K3, we are having V1. So this way you can see we are having a key and list of values. We will perform some sort of aggregation on top of this, and generally we get the output. This is what the reducer phase does. Now here what we will be doing, here in our map function we will be generally pull out the year. That in map function generally we are writing the business logic. So we will pull out the year and the air temperature, because these are the only fields which we are interested in. I'll just show you the database, or I'll just show you the data set. So in this case the map function is just kind of a data preparation phase, if you see. So it will set up the data in such a way that reduce function can do its work. And here the same mapper can be used to prepare the data, and you can write different reducer to find out the maximum temperature for each year, minimum temperature of each year, or average temperature of each year. So basically mapper would not change, only your reducer logic would slightly change to find out maximum, minimum, average temperature for each year. And here the map function is also a good place to drop the bad records. We will see there are some flags which will indicate the record is good or bad. So we will filter out all the missing or erroneous records. So there are some lines, in your data set. I'll just directly show you the data set. So this is for 1901, year 1901. Let us open the same in the notepad. So this is one record, guys. If you see, the very first record is the one record. Then starting from the second line, it's a second record. And here if you see, there are several fields. Basically these fields are having some meaning. At each fixed location you are having some field value, and that you can understand from the NCDC website what is the schema of this particular file. So we are not going into much detail about the schema of this particular file, because we are interested only with two things currently: the temperature and the corresponding year. The temperature you can find it from here, 1901. This is nothing but a date, 1901-0101. Okay, then here you can see 1901-0101. Then this is for 1901-0102. Okay, so that may be in YYY MMDD format, but right now I'm interested only for this one, 1901, which would be same across the file. If you see, there are so many records in this, almost 1095, and this is the fixed location where the year is there. Then corresponding temperature, if you see, that is there at this particular position, which is this minus 0078. So it is recorded minus or plus, and it is multiplied by 100 minus to give the same precision, minus 0078, minus 0072, minus 0094. So at various position, at various location of the world, and at a particular date and time, this is the temperature which is recorded. And we are interested only with these temperatures regardless of its place or anything, right? Because we just want to find out for this year what was the maximum temperature recorded by NCDC. Okay, so we are interested only with year, which is 1901, and this temperature value. So we will filter out all these things, And there is a when we will see the program, we will see there is a flag which will tell you whether the data is bad data or a good data. So we will filter out the bad records as well. So here in this particular example, if you see, it's a data for 1950, like we have seen for 1901, and then plus 000, then 1950, then plus 0022, 1950 minus 0011, 1949 plus 0111, 1949 plus 0078. So the mapper would get something like this: 0, comma, and this entire line. Then 106. That means all the characters maybe like 105 length, and then from 106 we are having a second line, and then the value would be second line. Then 212. So these are nothing but the character position for starting of that line, and then we are having the entire line. So mapper output would be something like this. Key would be nothing but the year, and value would be nothing but the temperature. 1950 0, 1950 22, 1950 minus 11, 1949 111, 1949 78. Now for 1949 we are having 11178. These are nothing but the values, list of values. 1950, then 0, 22 minus 11. So this is nothing but your key and list of values. And then finally you apply the max function on the list of values for each key, and you will find out the values. So this is the diagram which is showing the same. So let us try to implement the same using Java as a programming language. So we have seen in our word count problem, we were using Eclipse, where we were having already which is already there at Cloudera machine, and we will be finally writing the code in Eclipse. We will create the class and all, and then we will generate the jar file. We'll export the code to jar file, and then we will run the jar file. So I'm having these files with me. Which are like 5 years worth of data: 1901, 1902, 1908, 1909, and 1910. So I'll put these 5 files in a folder at HDFS. We will that would be our input part. So I am taking all these 5 years of data, and then from this data set, like we will iterate one by one each year, and then for each year we will be finding the maximum temperature. Like 1901, then what is the maximum temperature? 1902, what is the maximum temperature? Likewise. So for that, I'm having 3 different classes. If you remember, in our word count, we have written everything in a single class file. But as I already told you at that time also, you can create different Java files which will represent each and every class. Like one for mapper, one for reducer, and one for driver. Driver means the code which contain the main method and your job configuration arguments. So there are the 3 classes over here. There are 5 input files over there. Let us try to dump all these things into our Cloudera machine. So I'm just opening the Cloudera machine. So I'm having this machine there with me. I'll just create a new project. Otherwise I can simply write in this same project for word count. Let us try to create a class file, and we will give the name highest driver, and maybe we will create to test NCDC demo package. Okay, and I'm already having this particular highest driver.java. I'll just explain you what exactly happening in this particular class. Okay. Then there are two classes, highest mapper and highest reducer, which are nothing but the mapper and reducer. We will create them as well. Highest mapper, and there would be highest reducer. So the code for highest mapper is this. And this is the code for highest reducer. Let me explain you each line one by one. So in the driver program, basically what we are doing is we are passing the highest mapper class and highest reducer class as set mapper class method. Job conf is nothing but your configuration object, okay, which is taking get configuration argument, and then highest driver dot class. We are just setting the job name to highest driver. Set output key class. Output key would be text. Output value would be int, which is all about the temperature. Then you are just setting the mapper class and reducer class over here. Then the input and output are nothing but the arguments which would be passed through the command line. So args of 0 and args of 1. Then file input format dot add input path, and you will add the INP as the input path and out as a output path, and then simply run the job using the configuration. And we are using tool runner dot run, and finally passing the configuration and the new highest driver, which is nothing but the class object, and then arguments. And finally this particular function will return the 0. This is a run method, okay, for the tool runner class. So this is implementing the tool interface and extending the configured class. So this is how basically your driver program will look like. Then we do have highest mapper class. If you see, it is having that classical thing, which is extending the MapReduce base, implementing the mapper interface, and the arguments will contain the input key value data type and output key value data types. So input key would be of long writable because this is a big data. So your that character position for the new line may surpass the integer range. So we are giving long writable. Then input value was text, which is all about that entire line. And then output key would be text and output value would be integer, which is all about the temperature. Then we are taking one static final integer variable missing, which is having the value 9999. And now highest mapper has to implement the map method, which will again take the same arguments, long writable key. I'm giving a variable name key of type long writable, a variable value of type text, and then there would be output collector collection, which will be having text and int writable, and I'm giving the name as output. So if you see, these all things are very much same we have seen in the word count problem. In the word count also we were having the same method signature. The difference lies in this map method implementation logic. So in the body of map method, right now what I'm doing, I'm just extracting the value from that value variable, but value variable was there in the text data type, so we have to convert to the toString data type. Just go through the MapReduce word count problem. I have explained each line one by one. So if you are facing any difficulties in understanding this code, then you can refer that particular module. Then line.substring. Now we are having a line. So let me just open this or copy these files over here. Let us have those 5 files. These 5 files. We will copy these 5 files over here. Yes. And now if you see 1901.txt, then here what we will be doing, we will be simply, in map phase, we will be simply process the data. We will simply prepare the data or, in a particular format. So 1901, we just need to extract this from this entire line. This is your first line, right? So here if you see, you just give some string function and retrieve this 4 digits or four characters basically. And that's what we are doing over here. So from line, we are, using the substring method, finding 15th to 19th character. Starting with 0 index, this is nothing but the 15th to 19th character. So here if you see, the column is 16. So yes, it would be a 15th character. So 15 to 19, and we are storing it in a year variable. Now let us have another integer variable, temperature. Then what we will be doing? We will be simply doing line dot character at 87. Now, if you see, we are interested with this particular 5 characters, right? Which are starting from 87. Okay, that would be the index because it is a 0 based one. And here you can see the column is 88. So basically we are starting with this 87th character index to 87, 88, 89, 90 and 91. These 5 characters, right? Now 87th character, if it is plus, then we will be having a positive number, right? It's a positive temperature. So basically we are interested only with the next 4 digits. But if it is minus, then we are interested with all those 5 digits. So if the line's character at 87th position is plus, then we will simply extract 88 to 92 only from that line. And then we will parse it to the integer. That means we will convert that string to integer and store it in a temperature variable, which is int. And again, line dot substring 87 to 92. Okay, in the else part, that means the minus temperature. We will be taking all those 5 characters, which is 87 to 92. And then we will be storing it into temperature variable again. So for plus, we are simply ignoring the plus sign, and from 88 to 92, 4 characters are taken as a temperature. And if it is minus, then 5 characters, including the minus sign, will be taken as a temperature variable. And finally, there is a quality variable string, which is from 92 to 93. That means here if you see, this is the logic basically. After minus 0078, the 92nd character or 92 to 93. Okay, now we are extracting this particular character basically. If that character is not equals to missing, okay, and quality dot matches is 01459, that means that particular character is having a value from 0 or 1 or 4 or 5 or 9, then you can say it's a valid temperature. So then only you will be generating the key value pair. Otherwise you will not generate the key value pairs, and you will discard that particular record. And finally we will be simply having the output dot collect, and then the new text year. That means the year which we have found, that would be your new key, right? So that year is there again in string, so we have to convert into Hadoop's MapReduce text data type. And then int writable temperature, you just need to convert the temperature which is in integer, but we have to convert into int writable of Hadoop. And finally we are having output collection, which is having a year and temperature. So basically list of key value pairs. So this is all about mapper class. Now what the reducer class will do, so again classical signature, highest reducer is the class name. It has to extend MapReduce base, and it has to implement the reducer interface, And if you see reducers key value pair, they would be text and iterable, and output would also be text and iterable, right? And then it has to implement the reduce method, again defining a key which is of text data type. Then for values, we will be taking one iterator of iteratable, giving a name values. And finally, you are having output collector, which is again having text and iteratable, given the name as output. Here the thing would be pretty much simple, because we will take a max variable. We will iterate through all the values in the iterator. So values dot has next, and finally values dot next dot get will be current one. And if max is less than the current, then current would be your new max. This is our classical finding the max value between two variables. That is the program, and it is there in the loop, so it will try to scan each and every value. Okay. And finally output dot collect, and then your key. And then what you will be doing, your max divided by 10, because I told you, right, they are multiplying by 10. So this is the NCDC format. So we just need to divide it by 10 and convert it into the int variable, and that would be nothing but your maximum temperature. Okay, so maximum temperature, whatever you are getting from the file, you have to divide it by 10 and convert it to the int, and finally you will get the output. So this is all about the coding part. Now let us export this program into a jar file, and we will run the jar file. Before doing that, what we will be doing, we will be uploading this 1901 and all these files, basically 1902, 1908, 1909 and 1910 to HDFS through on one directory, like because the data should be there at HDFS, right? So let me just do that. We'll see on like where we can dump the data. Root user Cloudera. Inside input data HDFS, maybe we can create NCDC folder over there. So HDFS DFS -mk dir, and we'll be creating a folder in input data HDFS NCDC. Okay. Let us see whether the folder is created or not. Yes, there is a folder NCDC. So in this particular directory, we will be dumping all the files. Okay, so HDFS DFS-put, and from downloads 1901.txt. Okay, we will be dumping to this directory. Yes, and here you go, your file is there. 1902, 1908, 1909 and 1910. I'll just put all of them. 1902, 1908, 1909, and finally 19 and 10. Cool. Then let us export this particular one to a jar file. So export jar, next, and finally mrwc max temp. I'm just giving the name like this: Hadoop mr max temp.jar. and I'm storing into desktop. Let us select the main class. So I'm selecting highest driver as a main class this time because the code is there for main class in the highest driver.java. So I just selected that, and if you see now, places desktop, and yes, so this is my file Hadoop mr maxtemp.jar. Let us run that. Hadoop dfs, not Hadoop dfs, but it would be Hadoop space jar file path, which is desktop mr, not mr, but Hadoop mr ncdc, not ncdc as well, it would be maxtemp.jar. Yes, then the input path from hdfs is nothing but um, let us give this one directly because default is root user cloudera, so no need to specify that particular one. And maybe the output we will be dumping to root user cloudera and mr output folder maybe, but that is there, right? So we will be creating mr output ncdc maybe. In the mr output ncdc can be the folder, and we will be just giving that one. Okay, so let us run this particular job. So basically it will connect to a resource manager, and it will run the MapReduce job directly. Okay, and this is the URL for tracking. You can also access the same using resource manager URL. If you go to resource manager, you can see in the running application you will have your application which was named as highest driver, right? Remember conf.set job name is highest driver. So this is the application ID basically. Application ID is this, which you can see from the program as well. Yes, this one is the application ID. It is running like map 0%, reduce 0%. That means it has started the mappers. Okay. If you want to see or track, then you can click on this tracking URL as well. So yes, total 5 maps are invoked over here. Maybe for each year it is invoking one mapper, and then this is the map progress. So map is 0%, 20%, 40%, then you can see 100%, and finally reducer is started, reduces 0% to 100%. So job completed successfully. If you see counter values, the number of bytes it read and written. Okay, what are the operations? Okay, then if you see launched map tasks are 5, reducer only 1 was invoked. Okay, then from the MapReduce framework, if you see, a mapper had input records 5473, output records 5472. Okay, then if you see, like, there are some shuffle errors, as then no shuffle errors are there. Then file input format counter, it is shown. Reducer output records are 5. That means we are having 5 years, right? So 5 years, 5 lines for each year, right? So that means one line for each year. That means total 5 output records. Okay, reduce input record is 5472. That means 5472 different key value pairs were there, and from it found out the this thing, the maximum temperature. Now let us see whether the output is as per the expectation or not. So yes, the job is succeeded. It has successfully completed 5 mappers and 1 reducers. And if you just go to MR output folder, there would be NCDC folder over here, and inside that you will find out the part file, right? As you know, the MapReduce job will always dump the data to the output path in terms of the part file. So now let us open this part file, and uh, part hyphen 000, yes, see, 1901, for that year the maximum temperature is 23. 1902 it is 15. 1908 it is 28. 1909 it is 27, and 1910 it is 29. So guys, this way if you see your maximum temperature for each year, okay, you can find out. So you can give all the files from maybe 1901 to 2020, and then you can see this has actually analyzed this big data. There were so many records, right? For each year you can see there were so many records. This is still some smaller data set, right? But at a higher level you can have many records, and it can easily find out the maximum temperature from this big data very easily and efficient way. Okay, now if you want to just tweak this program to find out the minimum temperature, then what exactly you need to do? You just need to change this less than sign to greater than sign, and that would be your minimum program ready, right? Because you just need to find out the mean temperature. Maybe the variable names you can change. So the mean temperature, if it is uh, greater than the current temperature, then current is what your mean is, that, like that. So that would be quite easy, right? And if you want to find out the average, then that also very easy. Now you just sum up all the variables, all the values basically in this loop, and then divide it by the total number of these values iterator, and you will be ready with your average temperature program. Okay, so this was all about the NCDC, data set, understanding the NCDC data set and finding out the maximum temperature. So we have implemented the same using Java as a programming language. So, um, so that you can get the idea how the things are working apart from MapReduce classical example, which we have seen in the last module. So now we will be starting with the unstructured data set. So now we will perform some image processing task using MapReduce. So MapReduce framework can be implemented using Java, and Java is having a very rich support for images, audio, video, this kind of unstructured data set. So basically, the unstructured data set where you are not having any particular structure and you want to get some information from that, or you want to do some analysis on top of that, then definitely Java is having a support of rich libraries for images, so that will help you to mine this unstructured data set. So the problem statement over here is I'm having basically, let us say I'm having these 7 images. These images are there with me, which are captured from different angles. If you see here, some mountains are there, some greenery is there. Then if you see the second image here, only tree is there. Then the third one where again like grass is there. Then fourth one here again, a landscape shot is there. So these images are there with me, and there are several duplicates images as well. Like if you see over here, I'll just show you basically what are the images I'm having. So in the downloads folder, I'm having several images. I'm having this 8 images basically. So you can see this second image is repeated over here, exactly same image is there. If you see 2 and 2 underscore 1, then 3 is there, then 4 is there, 4 underscore 1 is there, 4 underscore 2, 4 underscore 3. All of them are actually a replica of each other. So we just want to find out distinct images. That means you need to remove the duplicates from the images. You need to mine the images, and you have to find out which all are the distinct images from these 8 images. What exactly we need to do for this? We have to write down again a Java code. We will be having the same MapReduce thing, like mapper is there, reducer is there, but here basically 2 jobs should be invoked. I'll just go through what are the steps which we require. So basically we need to understand a concept of sequence file. Sequence file is nothing but a flat file which will have binary key value pairs. Okay, till now we have seen only text input file, text output file, but now we will be introducing with sequence file. So it is extensively used in MapReduce as input output format. Basically internally the temporary output of the mappers we have seen, right, like that part hyphen m hyphen 000. So that is nothing but the temporary map output. That is also a sequence file only. So what we need to do basically, I'm having these 8 images, right? So I'll just explain in the whiteboard. So let us say you are having these 8 images. So first of all, you will convert these images into a sequence file format. And images are there in binary file format. So we will write a program, to convert from binary to sequence file format. Once you are having a sequence file format, basically, then it would be quite easy for you to play with all these images, because they are now in sequence file format, which Hadoop very well understands. So after this, again, this is nothing but your first job. Let us say this is your first job, to convert the binary file to sequence file. Now the second job will take this sequence file. It will find out the hash value from this file, each file, and then it will compare the hash values. Okay, and wherever it finds the hash value are same or repeating, then you can say those images are nothing but the same replica of existing image, and you will know like this is a duplicate image, and you can simply discard it. So this way, your second job will be again having some a driver program, mapper program, reducer program, which will actually find out the duplicate images or image dupes. This is your second job. So this way 2 jobs we have to write. Okay, we will write down in the same Eclipse editor. We will be exporting the code to a jar file, and finally to run the jar file, we have to pass different main method. For the first job we have to pass a different main method. For the second job also we have to pass the different main method, because main is nothing but the driving factor for all the program. So that I'll show you how you can do that. Before that, let us go through the code for that. Let me open Eclipse. So there are in total, if you see, there are 4 files, 4 Java files, and the very first one is binary files to Hadoop sequence file. And all these 4 files are there in the package test image proc. So here we will be importing the several classes which are related to byte array output stream, which are for Java input output. What exactly you need to do? There is a class binary files to Hadoop sequence file, mapper. which is again extending to mapper class, and here you will be having object as a key, value would be text, and output key would be text and in bytes writable because you are converting them to a byte array, every image to a byte array, because that is what the computer understands. So the map method is there, which is taking some variables key and value of object and text type, and then a context object is there. And finally, if you see what we are doing, so value dot toString, value we are taking, value would be nothing but the path of the image. Basically here we will be passing the path of the image, which is nothing but the URL, and path would be something like this. At HDFS, where the path, where the image is, that particular path you are passing over here. So this is nothing but the image's location, which will pass as a command line. Inside this file, each and every line will have a separate image path. So we will just get that particular file system URI, and finally in the try and catch block, what we will be doing, we will open that particular path, we will open that particular image which is stored at the path mentioned in the image's location. And what we are doing, we are reading that particular file, okay, and finally we are simply outputting them into a 1024 cross 1024 matrix byte array. Okay, so buffer is nothing but a byte array, okay, and we are writing into that. And finally your value means nothing but that particular path is your new key, okay, that would be our new key, and the new value would be nothing but that b out is nothing but that byte array output stream. So b out dot 2 byte array, because b out is again a data type which we need to convert to byte array, and we have to again convert into Hadoop specific data type, which is bytes writable. So this way finally you are getting a key value pair. Okay, and we are having only the mapper task over here, no reducer task for the first job. Why? Because we don't want any fancy aggregations to perform over here. We are simply having conversion of each image from sequence binary file to sequence file. Okay, and that's what we are doing over here. So no reducer is required. And finally, in this binary files to Hadoop sequence file, in this class there is a main method. In the main method, again classic thing, okay, all the parameters related things we are passing into the main method, like configuration object. Then we are creating a new job object, and here we are passing the particular job name. This is something differently. We are passing the job name. We are simply using the job class over here. Okay, so that is quite possible. So job.set jar by class, so you will be passing the main method class, then set mapper class, set output key class, which would be text, set output value class, which would be bytes writable, then set input format class. Input you are passing as a text input format, because you are passing the the location, the path of the images. And set output format class is nothing but the sequence file output format, because the output is there in the sequence file format. So input and output, these two things are different over here, which was not the case with NCDC dataset or the word count. Okay, so this is something differently we have to do. And then add input path, and arguments of 0th index would be nothing but your input path, and args of 1 would be your output path. So this is the example, guys, where we are converting this particular binary files to Hadoop sequence file. So what we are doing currently, we will be running this particular jar file with this as a your main class. So main class we will not select. Basically we will simply export this jar file. Let us export jar file. Next, and I'm giving the name as Hadoop mr image proc.jar in the desktop. So next, And main class, just give it blank because we are going to run the same jar file with two different main classes. So don't select anything. Okay, you are having a privilege to select not select, but to specify the main class in your Hadoop jar command. So simply, I'm already having that jar file, I'm just overwriting it. There are some warnings, but that is completely fine. And now if you see on desktop, you will be having a jar file which is Hadoop mr image proc.jar. Okay, now let us try to run this jar file and create those sequence file. So Hadoop jar, then jar path, which is Hadoop mr image proc.jar, then the input path. Now before input path, basically you have to specify the main method because you have not selected at the time of generation of jar file, right? So your main method would be this one, right? Binary files to Hadoop sequence file, and it is there in the test image proc. Test image proc, that is the package name, and then dot the class name. Okay, then space the input. Input would be root user Cloudera images. Inside the images there is a images location.txt. This is the file where this is the file where you are having path of all the images, and if you see, the images are there, actually .jpg files are there at this particular path, which is root user Cloudera images. Inside that 1.jpg, 2.jpg, 2_1.jpg, like that. So I have just specified these 8 paths over here in this simple txt file, and that would be your input. So yep, so it would be root user Cloudera images underscore location. I think that is the name, images underscore location dot txt. Output folder, you can give anything, it would be created automatically. I'm creating root user Cloudera image proc out. Inside that, job 1, maybe, let us say, that is your output folder. So it would be created automatically. Now whenever I am pressing the enter, it will start a MapReduce job. Basically it is connecting to resource manager and it will start a MapReduce job. Now this particular job would be purely map only job because you have not specified reducer class over here, and this map job will simply convert your binary files to Hadoop sequence file. And here multiple binary files would be there. They would be converted into just one sequence file format. That is something we need to remember. Yep, so MapReduce job has started. Map is 0%, reducer is 0%. You can actually, track the same on your resource manager. Okay, map is completed in no time. Yes, your MapReduce job is completed, and map input records were 8, output records are also 8. And now let us see basically the format, how it is looking at HDFS. Okay, so yes, now if we go to root user Cloudera output folder, it is mr output, not mr output. What output we have given? We have given image proc out. Yes, so we will go to root user Cloudera image proc output job 1, and here it would be a part file. Okay, now This particular part file will be having a sequence file. Okay, now this would be input to our second job. So what we are doing in the second job, let us see that. So there is a image driver.java file. So now for second job, I have divided the main methods driver class or driver Java file to a separate one. Then mapper and reducers are also written in a separate class. That is fine, but I have given for each class a separate Java file. So there are three files. One is image driver.java, second one is image duplicates mapper.java, and third one is image dupes reducer.java. Now if you see in the image driver what we are doing, it's classic thing like what we have done in the first job also, like creating the configuration object, then job class object, just setting the jar by class, setting the mapper class, which is image duplicates mapper dot class, set input format class. Now input would be sequence file format, right? And set reducer class, which is image dupes reducer, set output key class. So output would be text. So basically in the output, the distinct images after removing the duplicates, whatever images are left, we are storing their path to one file. So it would be text format, right? So output would be output key class is text, output value is also text. Okay, and file input format dot add input path. So args of 0 you are passing and args of 1 you are passing over here. Now all the main things which are there we need to understand is there in the mapper class. So there is an image duplicates mapper, which is extending to the mapper class, which is accepting input key value as text and bytes writable, and output is text and value output key and value both are in the text data type. So map method is there. Again, I am declaring some variables like key and value with corresponding type like text and bytes writable. Now what we are doing over here, we are basically using a MD5 algorithm, message digest algorithm, to check the hash value, to generate the hash keys basically for each and every file. So what we are doing, calculate MD5, and whatever value we are having, that means that sequence file which we are receiving, right? We are generally passing like get bytes, value dot get bytes, that means converting into the bytes, and we are passing that into the calculate MD5. Okay, so here calculate MD5. Now if you want to just see that sequence file which would not be easily readable by us, but let us download and see how it looks like. So part-r open. Yeah, you cannot actually open it. Yeah, we will try to open using gedit, but yeah, it is not opening. But I can just show you something which I'm having. Yeah, it would look something like this. So here for every file, its sequence file format would be mentioned over here for each file, like 1.jpg, 2.jpg, and those file paths are nothing but the key, and value is what your sequence file or the byte array which is generated for it. Okay, so now simply what we need to do, we are simply generating a message digest instance for MD5. MD5 is an algorithm, and we are creating the object MD for this particular type message digest. So md dot update, and we are passing the image data. Image data means nothing but your byte array. Okay, now md dot digest is a method which will return again the byte array, and we are storing it into the hash variable. Now what we will be doing, we are taking one string, we are generating for hash dot till hash dot length, we are simply generating the hexadecimal number for that hash value, and that would be your hex string, and that is written over here, which is stored in this MD5 str. So we are converting the hash value to hexadecimal value. Now MD5 text we are MD5 str we are converting into the text data type of Hadoop, and MD5 text would be your variable, which would be the key, and the value would be nothing but the original key, which is nothing but the path. So MD5 text is your key now, and the original key is your value now. And that way the mapper class ends over here. And then it comes to the reducer class. So in the reducer, again, the reduce has to, uh, take the arguments. Okay, it is extending to the reducer class with text, 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 text. That means all the input key and value and output key and value, all of them are text data type. And finally, in the reduce method, I'm having an iterator of values. Now, simply what you need to do, you just need to take an image file path, which is of text type. So key, whatever is there, which is nothing but the MD5 hash values, uh, uh, you know, MD5 hash values, and for all the images file which are associated with it. For each MD5 value, we need to take only the one file, only first value. Okay, so what we will be doing, we generated the hash value, right? Now, from these values, okay, basically from these values, you just need to see file path is which is of text data type, which we are storing into again a image file path, and we will simply break this for loop. So each and every hash value we are storing only one time, okay, and simply breaking the loop. And then again, we are not doing any operation over here. So finally the result would be there in the image file path, and key, original key, is nothing but over here the value. Okay, so this way, like, only the first hash value we are taking, and that way it will ensure all the hash values are taken only one time. That means you are deduplicating your images. Okay, from those 8 set of images, if anything is repeating, then repeated hash values won't come. That means that image would be discarded. Now let us run the same program with the second job. For the second job, what we need to do, the output of the first job would be input to the second job, right? So over here I'm simply the output path was there, I'm simply giving it as an input path, and then we will change the the main method now. So the same jar file would help us, image driver, that is the main method, image driver. So test image proc.image driver, input path is nothing but this job one's output, and finally the output path, something you can specify, root user Cloudera image proc out job 2. That's it. So now it will again connect to resource manager. It will submit a job which will take the output which was generated as a part of job 1. Okay, so there it's a sequence file. Okay, and now from the sequence file we are getting the hash values, and from the hash values the unique hash values would be stored only one time, then rest of the things would be discarded, and that way you will get paths of the distinct images. That would be the output. So you will be getting a file where distinct images path would be there. So map is 0%, reducer is 0%, map 100%, reducer 0%, and job is completed. Let us see whether we are getting the output or not. And job 2, we are again having a part file. Let us download that file. Yes. So you can see only 4 images paths are there, which is 3, 2_1, 4_3, and 1. You might be thinking, why for 2.jpg instead of 2.jpg you are getting 2_1, and for 4.jpg you are getting 4_3. That is because the mapper may submit these hash values in any random order. So that is the reason basically there are 3 or 4 repeating images. Any image can come first, and we can take that image and we can break the for loop for that particular image set. So for all the matching images, this hash value would be same. So 4 underscore 1, 4 underscore 2, 4 underscore 3, 4, for all of them this would be the hash value. So it has taken that hash value only one time, and finally it has broke that for loop so that other duplicate images won't be repeated. So 3.jpg, 2 underscore 1.jpg, 4 underscore 3.jpg, and 1.jpg, these are the 4 distinct images from these 8 set of images. So this is what we wanted to achieve, and we have achieved using Java programming language MapReduce framework. So this is how the unstructured data set can be processed using MapReduce. That is quite possible. Okay, sky is the limit for this particular area. So there are so many deep researches are going on, and many algorithms are there which will help you to write down the code in Java, Python, or any other programming language. And MapReduce is having a wide variety of libraries for this sort of unstructured data which you can mine. Let us have a quick recap what we have seen in module 5. We tried to understand the NCDC dataset structure. We analyzed weather dataset using Java MapReduce. We saw image processing using MapReduce. We performed one problem statement like discarding the duplicate images, and we have solved the same using Java MapReduce. So thank you very much. This is end for module number 5. Don't forget to like and subscribe.